we've got an equation here, a literal equation, because it's composed of all variables or all letters. So we want to solve this for r. So first of all, you can see it's a fraction, so we always handle fractions the same way, right? We get the LCD, which in this case is r squared, and then we write that r squared next to each original term, right? What we're going to do is multiply both sides by r squared. So we essentially just write it right next to each term. So I'll do it this way. I'll write it as r squared f equals r squared dot times KL over r squared. On the right side, the r squareds cancel. That was the whole point. So now we're at r squared f equals KL. Let's divide by that f. So we'll get r squared equals KL over f. And then what we'll do is we'll take the square root of both sides. The square root of r squared is equal to the square root of KL over f. Now, because we don't know anything about r, I mean, there's no picture here. We don't know if r is positive or negative. We don't know if it's a length or not. So because we don't know anything about r, what we'll do is take the absolute value of r. That's going to be the square root of KL over f. And now when we remove the absolute value, this is where we get plus or minus. So r is equal to plus or minus the square root of KL over f. In number 3, we're given another literal equation, and we want to solve this for f. So first of all, I see f is under a radical, so why don't we undo the square root by squaring both sides. So I'm going to indicate it here. I'll get p squared equals, now quantity, kf squared. So this will be p squared equals, now when you square a square root, the radical comes off. So you get kf. Well, this is nice. I'm solving for f, so why don't I just divide by that k? So I'll get f is equal to p squared over k, and that's it.